make the product that the world can't do without. How do they do it? In fact, there is no natural metal called steel. To make it takes a kind of modern-day alchemy. And it all starts with iron. Iron is the basic ingredient of steel, and it's found in rock. Rock that is rich in iron ore is mined all over the world. It's ground down and shipped to steelworks. And in the English town of Scunthorpe, it takes 4 queens of England to turn it into steel. Introducing Anne, Mary, Bess, and Victoria. These are the 4 furnaces of the Chorus Steelworks. And here, pulverized rock begins a journey of transformation. Iron ore is basically iron oxide, or iron chemically bonded to oxygen. The problem is, to make steel, you need to get rid of the oxygen and separate the iron from the rock. To do this, you need to melt the rock. The iron ore is hauled up to the top of the furnace in containers the size of garbage trucks and then dropped into the furnace. Then a huge amount of hot air is blasted up through the iron ore, and this is where a blast furnace gets its name. The rock is melted at a temperature of 2000 degrees centigrade. No longer iron ore, now it's molten iron. From here, the iron is poured into a train. No ordinary train, of course. This is called a torpedo. It's specially insulated to carry the 1500 centigrade molten iron. Every day, 10,000 tons of molten iron are moved to the part of the plant that will turn it into steel. The molten iron is poured into a huge drum which can hold 350 tons of iron in one go. It looks like liquid fire, but in only 30 minutes this molten iron will be turned into steel, and it takes just 3 steps. Step 1. Add scrap metal. An odd thing to do, you might think, but the scrap helps to control the temperature. Step 2. Pour the iron on top and mix in a secret ingredient. Lime. Sounds like a cocktail. It's going to be more like a volcano. Step 3. Add oxygen. We didn't want it before, we do want it now. Funny business, chemistry. The next step is to remove impurities, like carbon. To do this, an oxygen lance is lowered above the molten mixture. It blows in high-purity oxygen at twice the speed of sound. This turns the carbon into a gas and the iron into steel. As the top of the vessel opens up, we see floating on the surface all the other waste products called slag, drawn out by the lime. Now we have high-quality steel bubbling beneath the surface. Next, the liquid is tapped from the bottom of the vessel, and we see steel for the first time. But how do you turn the steel into something useful? Rail tracks need long, thin steel. Pianos and suspension bridges need strong, thin wire. Cars and washing machines need sheets of steel. The hot steel goes through a process of water cooling as it's drawn through cooled rollers and water sprays. Then the hot steel is cut to length by automatic gas burners. Even after it stops glowing red hot, it still takes several hours to cool down. And then it's ready for anything and everything. Steel has the weight of the world on its shoulders. Five ordinary objects, five extraordinary stories. Coming up, in almost every city all over the planet, the movement of the world's 450 million cars is controlled by the world's secret traffic conductors. Traffic control, next on How Do They Do It? Every day, 3 billion people living in the world's cities have to battle their way from point A to point B. Cities are exciting places to be, but as more people decide to live in them, getting around becomes increasingly difficult. The congested rhythms of drive times and rush hours have become part of our everyday lives. Of course, the better you know a city, the easier it is to find a way to avoid the jams and the hold-ups. But if you think it's just you choosing a route to work or even deciding whether to turn right or left, you're wrong. There are other forces at work manipulating traffic flows, influencing the route you take, and even the speed you drive. Welcome to the dark arts of traffic control. It all starts with the traffic light. In Poole, on the south coast of England, traffic light manufacturer Siemens is developing ways to take the traffic light into the 21st century. Everything from super efficient lights to the brain of the traffic light, the circuit board. So why does a traffic light need a brain? Because they talk to each other. At this London junction, there is a traffic light. There's also a piece of wire buried just beneath the surface of the road. This wire forms a circuit. When traffic passes over it, a signal is sent to a box at the side of the road. The circuit board is counting the number of cars passing through the junction. And if the traffic gets too busy, it will allow for more green time to alleviate the congestion. This system is called Scoot, and it's monitored by the secretive traffic conductors of London. Introducing London's Traffic Control Centre, the LTC.
Kew Bridge is looking slow.
Have we assessed what's going on at Park Lane?
Notting Hill Gate, between them and have a little hands around.
An incredible 21 million journeys take place across London in any one day. And though you may not realise it, these guys are managing every move using 5,000 traffic lights and 1,200 closed-circuit TV cameras positioned all over the city. With them, traffic can still be pretty sticky, but without them, gridlock. And today, they've got to cope with disruption caused by the largest street festival in Europe. One million people have descended on Notting Hill. All the roads in the area have been closed. A lot of traffic has had to be diverted, and that has the potential to cause havoc. It's a massive headache for the LTC.
We don't have much to do with the actual event. We are managing the network outside the event.
The controllers monitor where the traffic that would have gone through Notting Hill is actually going. When they spot the hold-ups, they go into action. To keep the traffic moving, they radio instructions to the traffic cops all over the city, freeing up traffic flows here and tightening them up there. Londoners think driving through the city is frustrating enough as it is. Without the traffic controllers, it would be a lot worse. At least that's what they say. Five ordinary things. 5 extraordinary stories. Since this program began, worldwide, 200,000 tons of concrete have been produced. 27,000 people have bought new mobile phones. 14 million light bulbs have rolled off production lines. And the number of cars on the planet has got closer to an astonishing 450 million. Even the most ordinary things have an extraordinary story to tell. We only have to watch and listen.